In the previous video, we have understood critical section problem. Now let's learn the two process solution. The solution should satisfy the three important criteria which we have studied in the last videos. That is mutual exclusion and progress, which are essential criteria, and the third is bounded weight, which is optional. We should give the solution for n processes, but to solve n processes it is very difficult. So we will first see the solution for two processes. We have two processes and we have used while loop here. So we have two processes P0, P1, and we have used while loop here. The condition is true for both the processes, so the loop can run for infinite amount of time. So since we have written while 1, so this condition will be always true, and this entire loop can run for infinite amount of time. Here I have shown generalized solution. Any process first goes to entry section. Okay, so this we have already discussed in the last video. Any process will first go to the entry section. If one process is in a critical section, then no other process will enter the critical section. So that is mutual exclusion. Then we have exit section here. If any process is going out of critical section, then we can bring in the second process in a critical section. After that, there is a remainder section. It is the part where a process is accessing a private resource, and in this section, process need not bother about critical section. Now, here we use a variable named turn. It's a Boolean variable having value equal to 1 or 0. We will start turn equal to 0. Both the processes are independent and any process can start anytime. Let's assume that P0 starts first. The first statement is while turn is not equal to 0. We have put semicolon after while loop. Then it becomes a trap. There is no body to while loop. If the condition is satisfied, it means if the condition is true, then the loop will keep executing and control will not go to the next statement. If turn is equal to 0, then the while condition will be false, right? And the program will enter the critical section here. Now, if the context switching occurs after while, okay, after while here, if the context switching occur after while statement, okay, and if the control goes to P1, then whether P1 can enter critical section? No. Why? Because what is the value of turn? Value of turn is 0. So while will be true. Okay, and it will not allow program to go in critical section. Okay, so when turn is equal to 0, then P0 will enter the critical section. Okay, and after executing critical section, it will make turn equal to 1. Okay, and then we'll execute remainder section. Now, if P1 starts executing after this, the while statement will be false at turn equal to 1. Why it will be false? Because this is turn equal to 1 now. So this will be false. Okay. Hence, P1 will enter a critical section. So P1 will enter a critical section, and after completing it, P1 will make turn equal to 0 and will execute remainder section. Okay. So here, if you see, the mutual exclusion is working. Only one process can be there in critical section for a given time, which is the second mandatory criteria, that is progress, right? Now we have to check mutual exclusion is satisfied. Now whether the progress is happening or not, that we have to check. What we have studied, that the process will enter the critical section only if it wants to enter the critical section. But here you must have noticed that there is a strict alternation or round robin. Once P0 is out of the program, can it re-enter it? No, because after P0, P1 must execute. After P0, the charge will go to P1. and P1 will give back the charge to P0. In entire solution, we have not asked the process if it wants to enter execution. So, this solution is not following progress. It is following strict alternation. If P1 does not want to go in critical section, then P0 should be able to re-enter the critical section. But this is not happening here. So, this solution satisfies the mutual exclusion, but this is not satisfying the progress criteria.